Hi guys, welcome to my channel. And today we're gonna talk about the random variable. In this lesson, we have three objectives of random variable. First, illustrate a random variable, discrete and continuous. Number 2, distinguish between the discrete and continuous random variable. Number 3, find the possible values of random variables. But first, we're gonna talk about what is random variable is. Random variable is a function or rule that assigns a real number to each outcome in the sample space of a random experiment. It's denoted by letter usually x. Another example, it is a set whose elements are the numbers assigned to outcome of an experiment. It's an outcome. Number 2, a random variable can be discrete and continuous. What the meaning of discrete? Discrete data can only take certain values. Example, the result of rolling 2 dice only has the value of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Meaning of continuous data. Continuous data can take any value within the range. Example, time in a race, you could even measure it to a function for a seconds. Next, the definition in terms of the samples or an event in the random variable. First, sample space, outcome, event, impossible event, sure event, simple event, confound event, independent event, dependent event, mutually exclusive event, exclusive event, complement event, event associated with or, event associated with and. First, sample space. It is a set of all outcomes of probability. We can represent a simple space using Venn diagram and tree diagram. Example, construct a sample space for an experiment that consists of tossing a single coin. The outcome could be labeled H for heads and T for tails. Then the sample space is a set with S equals to H and T or head and tails. Second is outcome. It is a result of a single trial of a probability experiment. Example, the Planet Bollywood offers chicken, beef, or vegetable, served with either French fries or mashed potato. How many possible dinner alternatives or possible outcomes are there in the Planet Bollywood? The total number of possible outcomes is 6, 3, and 2. This principle is called fundamental counting principle, and the rule is as follows. Third, the event. It is a collective of one or more outcomes of an experiment. It may be simple or compound event. Example, getting a tail when a tossing a coin is an event. Rolling an even number 2, 6, or 4 is an event. Fourth, impossible event. It is an event that cannot occur, has zero probability to happen. Hindi na daw siya Example, in a flipping a coin once, an possible event could be getting both a head and a tail. Fifth, sure event. It is an event that certain to occur has probability equals to 1. Example here. Obtain the number between 1 and 6 when rolling an ordinary die. The probability of a sure event has a value of 1. The probability of an impossible event has value of 0 is equal to 1 always. Sixth, simple event. Any event consisting a single point of sample space. Example, the probability of drawing the ace of hearts from a deck of cards is 1 over 52. Seventh, compound event. Any event containing more than one single point of a sample space. Example, the probability of drawing a red ace from a deck of cards is 2 over 52. The red card is 26 cards, ace has 4 cards, then both of the red of ace of hearts and the red of ace of diamonds at 2. Number 8. Independent event. Two events A and B are independent events if the fact that A occurs does not affect the probability of the B occurring. The formula is BAB equals P open parenthesis A close parenthesis, or PAV equals P open parenthesis B close parenthesis. Example, you toss a coin and comes up with heads 3 times. What is the chance that the next toss will also be a head? The chance is simple, 1 half or 0.5 or 50%, just like any toss of a coin. Number 9. Independent event. Two events A and B are dependent events for which the outcome or occurrence of event A affect the outcome or occurrence of event B in such a way that the probability is changed. Example, removing color marbles for a bag. Each time you remove the marble, the change of the drawing out certain color will change. Number 10. Mutually exclusive event. Two events A and B are mutually exclusive events if they cannot occur the same time. Example, tossing a coin, head and tails are mutually exclusive. Cards, king and aces are mutually exclusive. Number 11. Exclusive event. A set of events is called exclusive if all the events together consume the entire probability simple space. Example, collective exclusive event contains all elements event for our experiment. Simple space with 3 collective exclusive event. In the pictures it says. Number 12. Complementary event. For any event E1, there are existing another E1, which represent the remaining elements of the sample space. Example, complementary event with a standard 6-sided die. Let's say we have rolling a standard 6-sided die, or our event is A is rolling a 5 or 6. Our complement A would then be rolling 1, 2, 3, or 4. Let's look the probability of A and A. P open A close parenthesis is equal to 2 over 6. Then P open parenthesis A is equals to 4 over 6. Number 13. Event associated with OR. If event E1 and E2 are associated with OR, then it means that either E1 or E2 or both The union symbol U is used to represent OR in the probability. Example: consider the experiment of tossing two coins. Suppose the coins are not balanced and correct probabilities associated with the simple points are given in the table. Consider the events. A. Observe exactly one head. B. Observe at least one head. Calculate the probability of A and the probability of B. Sample point. Head and the probability of it is 4 over 9. Next, head and tail. The probability of it is 2 over 9. Tail and head. The probability of it is 2 and 9. Then last one is tail and tail. The probability of it is 1 over 9. Last one, event associated with end. If two events E1 and E2 are associated with end, then it means the intersection of element which is common to both the event. The intersection symbols this is used to represent end in probability if two events E1 and E2 are associated with end. Then it means the intersection of the element which is common both the event. The intersection symbol this is used to represent end in a probability. Next, dependent versus independent event. What is the probability of getting certain marbles in a jar with 5 reds and 2 blues in the sample space? In the independent event, example, suppose you spin each of those 2 spinners. What is the probability of spinning an even and a vowel? First, 1/2. 3 even out of 6 outcomes. In a vowel, 1/5. 1 vowel out of 5 outcomes. The even and vowels is 1/2 times 1/5 equals 1 over 10. Independent event, 6 in 5 is 2 blue and 5 red. Separated, first event is 2 blue, 2 red equals 2 in 4. In the second, mean 1 blue and 3 red equals 1 into 4. Next, addition versus multiplication rule of event. Addition. PA or probability A or V equals probability A plus B plus probability B. Example, rolling 2 dice, what is the probability of getting the sum of 3 or probability getting the sum of 5? In the table, you can see the 3 and 5 that the sum of 3 is 2 over 36 and the sum of 5 is 4 over 36. 2 over 36 plus 4 over 36 is 6 over 36. Then it's equals to 1 over 6 times 100. Then it's equals to 16.46% that we getting the 3 and the 5. Multiplication. Probability A and B equals probability A times probability B. Example, a dice. What is the probability getting a 4 and other 4? You can see in the table, that's it. 1 over 6 times 1 over 6 equals 1 over 36. Times it to 100. 2 over 48% that you're getting the 4 and the another 4. First, score of the student in the summative examination. Score. Very good. What is that? Discrete. Very good. Number 2, amount of paint used in the building project. Amount. This amount continues. How long the student at their lunch? How long? Continues. Number of gifts received by 20 students during Christmas season. Number of gift. Number is discrete. Number 5, weight of 8 randomly selected mathematics books. Weight. What is weight? Continuous. Of the random variable. Example number 1. Expose a coin tossed twice. Let x be the number of heads that occur. Find the possible outcome of the random variable is x. As you can see here, its possible outcomes is head is 2. You can see that in our table. Example, wala na. Write all possible outcomes of each random variable. Number 1. Let x, the number of even number outcome, is rolled in the die. X is equal to 2, 4, 6. Number 2. Let y, a weight in mg or a sugar that doesn't exceed to 80 milligram. 1 minus 79 is here, and 0 then. Number 2, let m, score of the student in 5-item test. M is equal to 0, 1, 2, 3, and 5. Number 4, let G, product of two numbers taken from the two boxes contains a number 0 to 5. Here, the outcome is 25. The 6 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15, 16, 20, and 25. Score is 25. Guys, thanks for watching. I hope you enjoy the video.